All right, this is our last section in chapter 1. This is going to be section 10. It's going to be a brief video, and we'll do lots of our practice in class. So in this section, we're going to talk about density and specific gravity. So density is a physical property, which means that we can measure it without it changing the substance. We can measure the density of anything really without changing what it is. It relates the mass to the volume. So the volume can be measured in a liter-based unit or a cubic length-based unit, like a cubic centimeter or cc or a cubic meter, cubic inch. And mass is usually going to be in grams for density, but it can be in any mass unit. You can have pounds per cubic inch if you want to. It doesn't really matter. So density is mass over volume. DMV is what a lot of people like to remember for density. Usually there's like a little triangle involved with memorizing density, and you cover up part of the triangle to get the formula. I don't really want you to rely on using the density formula to solve for density. I want you to think about density as a conversion factor. So one of the things that I'm going to talk about a lot probably when we get more into conversion factors, which will be, we're going to use it all semester, but we'll get really into it when we talk about chemical reaction stuff and math with chemical reactions, is that anytime you can relate two units to each other, that's a conversion factor. So density relates mass to volume. So we can say this much mass equals this much volume. That's a density. So if I give you a density of 1.05 gram per milliliter, anytime you see this slash or you would read the word per out loud, I want you to think about it as really saying equals 1. So let's kind of restate this. 1.05 grams per milliliter. Let's write it as 1.05 grams. Instead of saying per, let's say equals 1 milliliter. Now you've got yourself a conversion factor between grams and milliliters. And I don't have to rely on algebra to solve this problem. If I have 5 grams of this substance and 1.05 grams equals to a milliliter, well, I can just pick one of these two fractions to use like a conversion factor. If I want to get rid of grams, think about which fraction would I need to use. So I can set it up like this. 5 grams, I take my density. Remember, this was once written as 1.05 gram per milliliter. That per and this line of the fraction are the same thing, because that per is really like saying equals 1. And so we're just kind of adding on that number 1, but that equal sign separates those two sides of that fraction, right? So you don't have to put it into an algebraic formula, right? We don't have to get the triangle out and put our fingers over stuff. We don't have to say, okay, well, I have to divide the density. If I want to go from mass to volume, I have to multiply the, no, we don't have to memorize all that stuff. We just say, okay, well, if this many grams equals this many milliliters, those two things are equal. I can use a fraction to not have to think, am I going to multiply or divide the 1.05? I just don't have to, the number 1.05 goes with the grams. The grams have to go on the bottom to cancel off the grams I have already. Therefore, I'm going to be dividing it. I don't have to think so hard. I can just use the fraction method to get that there. So start thinking about anytime you see per, rewriting it as equals 1, and then knowing, oh yeah, I have a conversion factor as an equality. I can turn that into a fraction, and then I can put as many of those fractions together as I want in a problem and solve something that looks really complicated in a way that I don't really have to think about multiplying. What do I multiply? What do I divide? I can just string it together in a bunch of fractions. You also want to think about significant figures whenever you're solving any problem in chemistry. And so kind of keep that in the back of your mind, especially as you're solving the homework and you're typing in your answers to things. Alex will want you to have the right number of significant figures. If you're getting something wrong, a lot of times it may be for significant figure reasons, just text me a picture of it and say, hey, I'm getting this wrong a lot. What am I doing wrong? And I can just tell you, oh, it's supposed to be this many sig figs, and then you can fix that. Specific gravity is more of a real world kind of thing. Sometimes we want to compare the density of a substance to the density of water at the same temperature. So like if this were water, what would its density be like? Or if I compared it to water at this temperature, what would its density be like? And we think about specific gravity is like if you were to put that substance in water, would it float or would it sink? If its density is greater than density of water, it would sink. If its density is less than the density of water, it would float. Because water is such an important substance on our planet, then specific gravity is actually kind of helpful in some circumstances to use to just say like, oh, this thing would sink in water or it would float in water. And so we can use specific gravity just to give us a quick little measurement of a real world use of something compared to water at that same temperature. So specific gravity has no units because if we see the gram and per milliliter is the same on top and bottom. So specifically for specific gravity, you want to use gram per milliliter or whatever the density of your water is, the density of your substance have to be the same units. So if, for example, if I gave you the density of water in gram per milliliter, but I gave you the density of substance in kilogram per microliter, you would have to do some converting to get them to be the same before you could do a specific gravity problem. So no units for your specific gravity. The units will cancel out. So one thing to note about specific gravity is that if your density of your substance is greater than the density of water, your specific gravity would be a bigger number, right? So if it would sink because the density is greater than water, your specific gravity would be a bigger number. If the density of water is greater than your density of your substance, it would be a fraction or a small number, like less than 1. So if your specific gravity is 1 or greater, it's either exactly like 1, then it's just the same density as water. But if it's higher than 1, your substance is going to sink. If it's less than 1, your specific gravity is like 0.5, that means your substance would float. It's a really quick little measurement of like, if you were to put this thing in water, what's it going to do? That can be helpful in lots of ways. And so you may see that in real life practices if you go about, whatever career that you're in. All right, we're going to do some practice with density and more conversion factors in class for this. This video is going to stay short. See you in class.